in all the models, I have told you a few things about controlling your model, making it less complex. Okay. So ElasticNet is the one which is considered as a complete linear regression package. Okay. So you can use this. Apart from that, let's talk about decision trees. So these are known as hyperparameters. अब आते हैं. So there is a thing called grid search CV. So grid search CV is nothing but a function. That's all. In all the models, I have told you a few things about controlling your model, making it less complex. लीनियर रिग्रेशन में क्या था कॉम्प्लेक्सिटी? मतलब हमने ये भी देखा था कि लीनियर रिग्रेशन कैन ऑल्सो गेट ओवरफिट. कैसे? लीनियर रिग्रेशन में हमने ओवरफिटिंग कैसे निकाली थी? What was the reason behind overfitting? The reason was कि it was the sampling, due to the sampling bias, कि one of the variable was showing, let's say, a perfect relation with the target. Due to that, after training, it gets high weightage and other variables were ignored. Remember, guys? And what was the solution we came across? इनको क्या बोलते हैं हम? And okay, this was in linear regression. ठीक है? तो usually क्या होता है कि we don't actually create different models. मतलब बाकी models ऐसा trend follow करते हैं कि they have hyper parameters. Linear regression is the case जहाँ पे उन्होंने model का नाम ही change कर दिया. Okay, it should not happen though. It should be a part of that. So use ElasticNet instead. ElasticNet is a mix of everything. You can implement linear regression, lasso regression, ridge regression, everything using ElasticNet. Okay, ElasticNet is a mix of everything. It has parameters called alpha and beta to control whether you have to use linear regression, simple linear regression without regularization, whether you have to use lasso, whether you have to use ridge. You can just use ElasticNet and maintain these two parameters. Okay, you will be done. Okay. So ElasticNet is the one which is considered as a complete linear regression package. Okay, so you can use this. Apart from that, let's talk about decision trees. So when was I? Decision trees. So I told you about some parameters that can control the overfitting of decision trees, because like main sample split in leaf, max leaf nodes. और भी है. I'm just noting that I can remember max depth. Okay, these four are the main ones. Okay, there are others also. So you can set any values. So there are default values also that you can look into the documentation of decision tree. What are the default values of all of these? So getting it, guys? So these are known as hyperparameters. Now there are two things. Okay, so एक मॉडल में दो चीजें होती हैं, पैरामीटर्स होते हैं एंड हाइपर पैरामीटर्स होते हैं. द थिंग्स दैट इज अंडर आवर कंट्रोल, they are hyperparameters. We can control hyperparameters, and parameters are the part of the formula. For example, in linear regression जो हमारे थीटाज होते हैं, थीटा 0 प्लस थीटा 1 x1 प्लस थीटा 2 x2, ये सारे पैरामीटर्स होते हैं. थीटा 0, थीटा 1, थीटा 2, ये पैरामीटर्स हैं. We cannot control them. They are calculated through training. Getting my point? And hyperparameters is something that we mention while instantiating the model. For example, how much regularization we want. Okay, we will mention the value of alpha in linear regression. Okay, and we can control how much regularization we want. Okay, so hyperparameter are the things that we control, and depending on the value of hyperparameters, these parameters also change. If I set alpha equal to 0, that means I am not doing regularization. So let's say theta 1 value becomes very high and बाकी सारे thetas become small. They are ignored. बट मैंने अल्फा को इंक्रीज करके 0.01 कर दिया. अब इसकी वैल्यू रिड्यूस होगी, इसकी वैल्यू इंक्रीज होगी, बिकॉज आई एम रेगुलेटिंग माय मॉडल. ओके, सो आई कैन कंट्रोल हाइपर पैरामीटर्स, एंड थ्रू हाइपर पैरामीटर्स आई कैन कंट्रोल actual parameters, but I don't have the direct control over actual parameters. Is the difference between params and hyperparameters clear, guys? Parameters are part of the formula for that machine learning model, and hyperparameters, they control the state of your model, like what kind of training you want. Okay, you can control how your model will train using hyperparameters. Okay, so that's how we try to tame complexity of a single model. ठीक है, let's say मैंने decision tree किया, I trained a decision tree, it got overfit. ठीक है, data was simple. ठीक है, so decision tree it will have low bias, it will have low training error and high testing error. ठीक है, what we will do, हम directly complexity उसका नहीं सोचेंगे, मतलब complexity कम करने का नहीं सोचेंगे, हम logistic regression पे नहीं आ जाएंगे सीधा. What we will do is we will try to control these features. Okay, we'll say that okay, I'll set the max depth to 10. ठीक है, उस केस में I will get a lower training accuracy. हाँ, lower training accuracy means high training error, a little bit high training error, but my testing error will be comparable. Okay, so I'll try to fix this, I'll try to fine tune this. इसको बोलते हैं fine tuning और hyper parameter tuning. Getting my point, guys? ओवरफिटिंग का मतलब ये नहीं होता है कि हम मॉडल चेंज कर दें. ओवरफिटिंग का ये भी मतलब होता है कि वी ट्राई टू कंट्रोल आवर करंट मॉडल इन अ बेटर वे. Okay, we try to find the best values of hyper parameters. Is that clear? अब आते हैं. So there is a thing called grid search CV. I'll tell you about the grid search part. CV part I will let you guys explore yourself. So what you will do is you will create a dictionary. Okay, and you will say that max depth, and in the list you will mention the values you want to experiment. Let's say I want to experiment 5, 10 and 15, and for min sample split you want to explore let's say 50 and 60. Okay, these are the these three values you want to try for max depth, these two values you want to try for min sample split. Okay, so you create a params this dictionary like this. So these will be your params dictionary, let's say, and just pass it. So, and you will say, okay, dt equal to, you have defined your decision tree like this, and then you will say your classifier will be grid search CV. Inside that you will pass your decision tree and all the params that you want to test. Okay, so this what the when you will do dot fit, finally you will do clf dot fit, you will pass your x train and y train. Now in the background, what this will do is grid search CV will fit decision tree for each of these combination. It will take max depth equal to 5, min sample equal to 50. It will calculate training and validation accuracy. Same thing, this is 5, this is 60. It will calculate again 10, 50, 10, 60, 15, 50, 15, 60. It will train your decision tree 6 times. Okay, and finally, it will give you the best result. Best result was, let's say, 10 and 60. Okay, this is the best result. So you will take that best model and you will use that. Okay, so grid search CV is nothing but a function. That's all.